Okay, and let's just see if we can get the chat going so that if any questions, we can see that and we can address the questions as they come through. Okay, so I'm going to start with Marvin Sketch. And Marvin Sketch is quite powerful, as we've dealt with. I'm going to draw the molecule we had, but of course, maybe what I will do in this case is I'm going to draw the correct tautomer, not the one we were given. And so I hope that is as close as I can. We've got some nitrogen atoms. That's an NH, and I think we've got an N at that point as well. Okay, and of course we've got an OH on the side. I'm going to change it there. So we've got, that is the correct tautomer, I think, of the molecule. We can do a conformational search, but of course in constructing this, we've got to make sure that all atoms are present, and not all atoms are present at the moment. So I'm just going to add explicit hydrogens. That's fantastic. And the problem is that we could get quantum mechanics to clean it up. That would take a long time. It's far more efficient to just clean it up here before we take it to quantum mechanics. So I'm going to then just quickly on the structure, I'm going to clean in 3D. And there we have it. So we have the molecule is now cleaned in 3D, and now I can file, and I'm going to save it as, okay, I'll call it 5rec, but I'm going to save it, in this case, I will save it as a Gaussian input file. And when it's a Gaussian input file, you'll see that there are two options, GJF or .com. Please, could you save it as a com? I'm going to call it 5rec.com. Or maybe let's call it 5recligand.com. Okay, so that's is one thing. So if we save it as a com file, then we will be able to use Gaussian on that, and we'll be able to do a calculation with Gaussian on that molecule using quantum mechanics to get really, really accurate geometries. We'll be able to do an optimization on that and get a really accurate geometry for that. I also want to save it as, I'm going to save it also as maybe, let's choose a format that's quite useful, like the PDB or the MOL2. So I'm going to search for a MOL2. Where's MOL2? Somewhere in this list. There we go. So .mol2. So I've got 5recligand.mol2 and 5recligand. And I just need to know what folder I was saving it to, because it's in documents. Now it's really important in documents. I've asked you to install a program called Notepad++ or an editor. And if I can go to documents, so if I can just open Explorer and just find my documents, here it's this one over here, this 5recligand.com. My computer thinks it's an MS-DOS application. It's not really, it's got .com extension. So what I can do with it, what I want to do is I want to open it with Notepad++. You can open Notepad++ and then come to it and open it, but you can also right click and you can ask to edit with Notepad++. And when you look at it, it's quite nice, because you can see each line you've got a carbon and 3 numbers to a terrible number of decimal places. And those 3 numbers are the Cartesian coordinates. So we've got the position of that carbon atom in 3-dimensional space. The other carbon position is over there, and so on. And you can see there's a nitrogen at that position, a nitrogen. You go down, you find oxygen, and so on. Right. But what we need to do with this is we need to be very careful with this file, and we need to edit it. And the way we edit it, you'll see that there's, after this line here, can you see there's a blank line here and a blank line here? You must absolutely be careful we don't touch those and we leave those in place, because if those are not present, then Gaussian won't recognize this as a Gaussian file. But what I want to do is I want to go to the top and I want to edit this appropriately for work on our cluster. And the way we're going to do it is we need at the top to have a memory directive. So we say %mem, and I'm just going to ask it to, that when it tries to use one of the computers, that it requests 6 gigabytes of memory. And that makes it, it tells Gaussian that when we run it, that there's a lot of memory available to it. And we need to also tell it that there are lots of cores on the processors that we're using. So we can do, there's nproc shared. And on our system, we've got eight cores available. There are 2 processors, each with 4 cores. But of course, if you use the CHPC, you'll be asking for 24 cores. So our things will run 8 times faster. But of course, on the CHPC, they'll run 24 times faster. So we've just got to make sure that those are present at the top. Now, should we mistype? Should we put additional spaces in? Should we mistype nproc shared? Then this will not run. So those 2 lines at the top have to be exact. And there must not be a space after them. It has to look exactly like that at the top. What happens afterwards is your molecule. It's going to be different every time. We mustn't change that. It's just those 2 lines that must be changed in order for this to be useful on the cluster. So I'm going to then save it. And now we've got the ligand done. If there may be one slight problem with it, we'll see with this file. We'll see when we copy it to the cluster. And there might be one further change we need to do within Notepad++, but I won't mention it now in case it comes through all right. Okay. Right, so now I have these 2. I've got 5recligand.com and 5recligand.mol2 that we've got. We need to copy those. And that was from yesterday. I'm just going to delete it so it's not interfering. So we've got these 2 files. I want to copy them onto the cluster. So of course, I've got to use WinSCP. And it's to carbon. And of course, there we go. We can log in. And I'm going to then copy both of those. So I'll just copy them one at a time. Ligand.com, ligand.mol2. And now I've got the system here. Apologies, I have not. I thought I'd taken off the waiting room. There shouldn't be a pause for people, but there we go. So I've managed to copy those across. And now we're in a place where we can get the cluster to do some calculations for us. Okay. So what we need now is we need putty. Okay. And putty again, we go to carbon with re.ac.za. And your username and your password. Okay. So here we have a terminal. And when you log in, I just want you to be aware of what I've written there. So you can see here, I've said that in order to use Gaussian, that's misspelled Gaussian, you're going to have to type module add Gaussian G09 E01. So that's an interesting thing that we're going to have to do. So please have a look at that. And you see it says this is, submission scripts will work if you've got mymolecule.com, because then you can just type this for the batch queue and add processes. And of course, we might not want to use the batch, we might want to use the del queue, in which case we can submit to the del queue. Okay. But the first thing I want you to do when you log in here is to see what is in your directory. And there's a function in Linux that you can type that will tell you what's in there. And if you type L and S, LS like that, and you press enter, it tells you what's in your directory. It shows you what's in the directory. And I'm sure, I hope that you'll type ls a lot. It's a command that we type incredibly lot just to show us what's going on. And that's one of 3 or 4 commands that I want you to know today is ls, and it just shows you what's available in your directory, what you've copied across onto the cluster. Now, if I want to submit that Gaussian job, I'm going to have to follow these directives that they've got here. The module add Gaussian, and it's G09E01. So I'm going to try and type that in. So if you type, you can, the tab key is absolutely fantastic on this. So what I've got is module. I'm just trying to type down, write down exactly this here to use Gaussian. So that's exactly what I want to type. So I've got module, and then I'm going to do add, and then I'm going to just type the first few letters of GAU. And there's only one thing that starts with GAU, and that's Gaussian. So if you press the tab key, it will automatically complete some of it. And so it's done up to the 0. Okay, so there must be things there. So there must be other things called G0 there. So I'm going to have to type the 9. And then I can press the tab. Okay, and there must be something else, and I can type the E and tab. When you eventually get it right, the tab completes it for you. So it's really fantastic. And then you can press enter. But ultimately, you could even type this in. You could type it in module add Gaussian G09.E01, but you'd have to make absolutely sure that where it was a capital letter, it was a capital letter. Where it's a 0, you type a 0 and not a capital O. So G09E01. It has to be typed absolutely perfectly. And that's why it's often nice to use the tab to complete, because the tab will never misspell. You just have to get the first couple of letters right, and the tab will complete what you're trying to do. If it's unique on the system, the tab knows what to type for you. Okay. Now, we've got to submit. I don't have a molecule called mymolecule.com. I've got a molecule called 5recligand.com, so I'm going to have to change this. And maybe we should just check what's running on the cluster first. So please type another command called qstat, which we did yesterday, just to see what's running. And you will notice that someone is using the batch queue, but not all the computers on the batch queue are being used. So we can still submit to the batch queue, but as more of us submit, some of you might want to submit to the del queue to use the other computers so we don't overload all the batch computers. So I want to now type in this command, but not my molecule. I want to use it for my own molecule, which is 5recligand, 5rec_ligand. So what we do is we do sub G09, not 09, 09. And shall I do it to the del queue? Let's do it to the del queue instead of a batch queue. So I'll submit it to the del computers. And instead of mymolecule.com, you would do mymolecule. So instead of 5recligand.com, you would do 5recligand. So 5rec, and you can use tab completion sometimes. 5-rec ligand. There we go. 5-rec ligand. So you leave out the COM extension, and then you must have the 8 on the end. Okay. And then when you press enter, you'll get a little message, and it'll say, if you do it to the batch, you'll just get a number, but to the del, it'll tell you a special queue has been done. And now when I type QSTAT, enter, if you are successful, you will see a little R, you'll see your name, your login name, you'll see an R saying the job is running. And of course, we are asking it to do an intensive quantum mechanics calculation. So it's going to take a long time for a result to come in. So don't expect results immediately. You submit it, maybe in an hour, check that it's still running or if it's completed. And at the end, we'll be able to copy a log file across. So if I can go back to WinSCP, in WinSCP, I know it's running because if I refresh, you can see there's a log file that's being generated as it's doing calculations on that molecule. Okay, so that's the first thing. That's how you get Gaussian to do quantum mechanical calculation on your ligand. We'll deal with the technicalities of using Gaussian in a couple of lectures' time. But for now, I'd like you to be able to at least get Gaussian to work. Okay, so if I type ls again here, you can see that by submitting the job, because it's running, if it was queued, nothing would happen. We just have to be patient. But because it's running, a log file is being generated, and that log file is the results of a calculation, and it's still, the log file is being created. It's still being, we need to wait for that log file to be complete before we do anything more. Okay, but what I'd like to do now is I'd also like to see if I can't use XTB to do a very quick calculation for me. Okay, the problem is, you'll remember that I said XTB requires an XYZ format. And I can't see, I've got a COM, I've got a job that's actually to do with a queue. I've got a log, that's a Gaussian output format, and I've got a mol2, but I've got no XYZ format of this ligand. And so what we've got to do is we've got to create an XYZ format. And the way we do that is we use Babel. So I use Babel, and it's minus, I'm going to take the mol2 file, minus I mol2, and it's 5-rec underscore ligand dot mol2 is what I called it. Okay, and then the output, I want an XYZ, and then I go and do 5-rec ligand is what I've called it. Why did I choose such a long name for this? I'm making work for myself because I have to type .xy. I've got to get this right. XYZ. Okay. And when you do that, it will convert. It takes the input. Remember, there are 5 words here. Babel's the first word. Input type, second word. Input molecule, third. Output type, fourth. And output thing, there are 5 words you've got to type in to get it. And if you choose a nice small name for your ligand, there's less typing to do. And then if we type ls, you'll see that there is definitely an XYZ file that has been created. Okay. So that's all we need available to us to do XTB. But of course, we need a module loaded on the cluster to do XTB work. And so you'll do module add XTB. Okay, so this is what you will need to do to be able to have access to XTB, is you will need to do a module add like that. And now we are ready to use XTB. Okay, XTB is so fast that I'm not going to submit it to the queue, and I'm not going to do QStat. I'm going to run it directly on Carbon, and poor Carbon is going to have to deal with everyone who's trying to run XTB. And so the way you run XTB is you call XTB by typing the name of the program, Then you type the name of your XYZ of your ligand, so 5-rec ligand, and you must have the .xyz, so XTB, and then you type --opt. So there are 3 words that you have to type to get XTB to work. You have to type XTB to call it, and this will only work if you've done the module add. And module add is important because without doing it, you'll type XTB and it doesn't know what to do if you type XTB. So once you've done module add XTB, then you can type XTB, name of a ligand. That has to be typed absolutely perfectly correctly. If there's a letter wrong, same with Gaussian, it won't work. It won't. So you've got to be careful, not only about capitals and smalls, but make sure that you use numbers where it's number or a letter where it's a letter. So it's got to be typed exactly. Okay, right. And then when you press enter, it might go too fast on Zoom for you to see. But can you see it's doing a whole lot of calculations? They're just numbers being thrown up on the screen. And now it's interesting because it's now complete. It took 4 seconds to complete that. And can you see that it's got a total energy for us? It's calculated total energy for our molecule, but it's written, the optimized geometry has been written to this file name called xtbopt.xyz. Okay, so that is really interesting. So we've got to be careful. If we run XTB another time, it's going to also write to this name. So we've got to be careful with this file and just maybe rename it or copy it somewhere safe before we run XTB again. But you can see it's done some really intense calculations on this. So you can go up and it's calculated the molecular dipoles and quadrupoles, but ultimately it's optimized the geometry using the semi-empirical type binding. That is really powerful. So that's how you can use XTB. If I go back to WinSCP and I refresh, you can see that after running XTB, there is the result of my calculation. There's a log file. That could be interesting to explore and to open and read through if you're really up to it. But what's really nice is this XTB optimized, my ligand's been optimized. I'm going to just copy it back, drag it back to my own computer. Here it is on my own computer, so I could explore and I could read, I could look at it. So it's, I could open it. But that is the XTB version. So maybe I'll try and open it on my local computer. So let's just open and see what happens. Okay, but it's in Marvin Sketch. Okay, so I'm not sure how to rotate in Marvin Sketch. I know it is possible to rotate. I wonder if Marvin View, I can open in Marvin View. Okay, no, Marvin View doesn't show. So I prefer, I think what I want to do, I want to open it with Discovery Studio. Open with Discovery Studio, that might show it. Okay. This is the first time I've run Discovery Studio on this laptop. Okay, so just be patient for a moment. Okay. And let's see if we can file open. There we go. Here it is. If it comes up looking like this, just right click on it and show it in graphics view. And there it is. So here is the XTB optimized version. What is really nice, and I think it's rather serendipitous that it's happened, it's not by plan. I seem to have started off with exactly the right conformation because what's happened is I've got an intramolecular hydrogen bond. You see that looks about right for a hydrogen bond. between the OH and the nitrogen on the correct tautomer now. Remember that I made sure I had the correct tautomer, okay, of that. Okay, so this is my XTB optimized, so it's optimized with semi-empirical type binding. So it'll be slightly better geometry than what we had before, okay? But of course, on the cluster, that Gaussian run that I submitted is still going, and we'll only be able to look at it tomorrow, okay? Or in a few hours' time. Are there any questions? So, if there are no questions, my question
Prof, I do have a question.
Yes? Question?
While letting these things run, so it's a thing that the computer must be on the entire time, or it can just run in the background.
So on the cluster, yes, what you can do is running. So if I do qstat here, it's still running. If I type exit, that cluster is still running. So you don't need it up and running. That cluster is working independently of your computer. So it's really nice because if you've got 5 jobs to do, you just submit them. You go QGO9, sub-GO9, and the name of the 5 different ones. You do first one, then the second one, third one, fourth one, fifth one. They all stay queued. Then you close everything and you do other stuff. And then the following day you come back and everything will have run by the following day. So you don't have to follow it. Yeah. So if I go back to PuTTY now and log back in, so to carbon, and that's the power of a queue. And what is interesting as well is, just need to remember my password. So if I do qstat again, I'm running still on the del Q is over there. So it still runs. What's interesting about this is I'm going to just type uptime. Carbon has been up for 273 days. Okay, so, and I purposely restarted it 273 days ago. It didn't crash. I purposely asked it to restart. So that tells you how stable the power is at the cluster. So you don't have to worry about power outages, load shedding. Carbon will go without going down, without turning off it won't ever drop it unless there's a huge crisis. Okay. Are other questions? Right, so my question to you is this. Would you be able to take one of your ligands, make sure it's clean and has hydrogen atoms, and I want you to do 2 things with it. I want you to save it as a Gaussian COM file, copy it to the cluster, and submit as Gaussian. The second thing I want you to do is save it as an XYZ or convert it to XYZ from a mol2 and do an XTB optimization of it. And then finally, if you do an optimization, can you view the output like I've done with Discovery Studio Visualizer? Okay, so please, if you struggle on any one of those points, please contact me. Let me know. Okay. Any questions before I sign off?
Prof, a question. When we're saving it as a Gaussian, can we have to do a Marvin sketch again, or we can convert the mode2 file that we have to a Gaussian?
My worry with that is there's a directive there which has B3LYP in it. Marvin sketch is put in automatically. And so that line, that particular line, Marvin sketch has got right. If you create it with another program and you get that line exactly like Marvin sketch has, then that would be fine. But if you've created in another way, you can communicate with me and we can try and get it looking right to calculate. So my questions, can I repeat my questions to you? My questions are, can you take one of your molecules, save it as a COM, and save it as an XYZ? I want the COM file to be submitted with Gaussian successfully on the cluster using subGeo9. And the XYZ, I want you to optimize using XTB. And then if you're able to do that, are you able to open and view the output of the XTB at the end using any program to view? Even Marvin Sketch is fine. So that's what I'd like you to be able to do by tomorrow. Please don't forget that this is all part of a bigger project that you're working on. And so ultimately, in the end, we want to optimize all 5 molecules in both ways. And you will need to include in that Word document you started yesterday what you've done today as well. Okay. Any further questions?
Sorry, Prof.
Yes?
I don't know if it's my computer, but when I try to save with Mol2, it just changes to Argus Lab document.
Changes to?
Argus Lab document.
Argus Lab document. You can't change the type when you save.
I do change it, but still, when it saves to my file, just go to Argus Lab.
But are you using Argus Lab to do that?
No, I'm using Marvin Sketch,
So,
but I have Argus Lab on my
no, it doesn't matter. No, you're probably doing it right. It's probably just that Argus Lab is associated with it.
Oh, okay.
It doesn't matter. I think you're probably doing it absolutely right. Okay.
Oh, okay.
Please, what would be interesting for me is when you open an Argus Lab, does it come up correct in Argus Lab? So that's my question. Because if it comes up correct in Argus Lab, we're doing everything perfectly correctly. Okay. Because these formats should be readable in more than one program. Okay.
Okay, Prof, thank you.
Right. I'm almost out of time here on the Zoom lecture. So if you have got further questions, you can always ask me to open a separate Zoom session on the same ID. You can singly or as a group, you can come together and say, please, we need, but it would help me on those if one of you are prepared to share your screen and for me to direct you. Okay. So I'll wait to hear from you. If I don't hear from you, we'll meet again tomorrow at 9 o'clock. Okay.
Prof, another request.
One last question, yeah?
Yeah, just a request. Can you also upload this like you did the last one? It actually helps.
Thank you for reminding me. Thank you for reminding me. I will do that. Okay.
Okay.
But please be patient. It takes some time to load to YouTube. Okay, but it will be there. Okay.